Okay, question 2. This question is about elements in the periodic table. So what property was used to arrange elements in early periodic tables? And you have to tick one box. Okay, so we've got one thing to do. Well, the atomic number, that's sort of Mendeleev, who we do that now, but we didn't originally. So the early periodic tables, remember, not the current one. And it was all really about atomic weight, so the weight of the atoms. In early periodic tables, iodine, I, was placed before tellurium, Te. Mendeleev placed iodine after tellurium. Figure 1 shows part of Mendeleev's periodic table. Okay, so there's tellurium, there's iodine. Suggest one reason why Mendeleev placed iodine in the column shown in figure 1. So he placed it there rather than there. So why was it he placed it here? Well, the whole thing, the reason Mendeleev put everything in columns, in groups, in the way he did, was because they had similar properties to bromine, chlorine and fluorine. So elements in the same column have similar properties. Okay, so you could say that iodine had similar properties to bromine, chlorine and fluorine if you like. Okay, but the key bit is the properties were similar. The table below shows the melting point of 3 group 1 metals. Okay, so we've got lithium, sodium, potassium. What state is lithium at 100 degrees Celsius? So use the table above and tick one box. So is it solid, liquid or gas? So we're looking at lithium here. Now the way I always do this, and I think I've done it before now in one of these videos, is I imagine the temperature there, this line, so temperature going that way, and I put on the fixed points for the substance I know. So lithium has got a melting point of 180 degrees Celsius. So I know that 180 degrees, see, this is lithium, that's when it melts. So that means on this side of it, it must be a solid. So we know it melts here, 180, so it's solid there, and we know it's liquid here. Okay, so if we go that way, if we're that side of 180, we're liquid. If we're the other side, we're solid. And at 180, when it's melting, we've got both. So at 100 degrees C, where does 100 fit there? Well, 100 fits over here somewhere, on this side, which means we're well into the solid region. So that is most definitely a solid. Complete the graph below. Use the table above, and you should complete the scale on the y-axis and draw bars to show the melting points of sodium and potassium. Okay, so first thing, we're going to complete the graph. We're going to use the table above, and I need to complete the scale on the y-axis, and then we need to draw bars to show the melting points of sodium and potassium. So we're 3 marks. Okay, so the graph is here, so I've just put this something slightly different. So I'm going to complete the scale first of all on the y-axis. So it's already started to scale off for me, and I can see here that 1, 2, 3, 4, 5, every 5 little squares. So 5 squares equals 10 degrees C. Okay, so every 5 little squares is 10 degrees C. So I'm just going to continue that here. So 100, so that's going to be 110, 120, 130, 140, 150, 160, 170, and 180. Okay, so I'm going to put all those values in. I'm not going to worry about, well, in fact I could go all the way up to the top, couldn't I? So 190 and 200. Okay, so I'm just going to go up in tens all the way up to the top. So that's the first bit, complete the scale on the y-axis. The next bit is I need to plot the values for sodium and potassium. So sodium is 98. So sodium is 98, so where does 98 fit here? So there's sodium, 98. So sodium is this bar here. So there's 90, there's 100. Well, each of these little ones in between is 1, 2, 3, 4, 5 little squares. So 5 little squares is equal to 10 degrees, then 1 square, 5 of them are 10 degrees, then one of them must be a fifth of that, must be 2 degrees C. So let's just go up in 2, so I've got 92 there. So 92, 94, 96, 98. Okay, there's 2 bars there, and it goes all the way across. Now, I would really use a ruler to do this normally. Can't believe I'm doing it without. That's dreadful, isn't it? Especially when it's something this straightforward. I want to make sure I definitely get the mark for this, because I know how to do this really well. And then I'm going to use the ruler to draw the line down to the bottom for sodium. So sodium's done. I'm then going to look at potassium. Potassium was 63. So there's potassium down there. Just put one in the middle there. So 63, so there's 60. Each little square is 2, so 62, 64, it's going to be halfway in between those 2 there. So I'm going to put a line there. It's going to go through the middle, and I'm going to leave a gap, 2 small squares either side. Down to there, and down to there. Make sure you do this in pencil, because then if you do make a mistake, you can always redo it.